In section 5.3, we're now going to discuss the ideal gas law. Good old Pivnert. Recall from the empirical gas laws that Boyle's law says that volume and pressure are inversely proportional. Charles's law says that volume and absolute temperature are directly proportional, and Avogadro's law says volume and the number of moles are directly proportional. In order to make this an equation, we can combine the N, T, and P together, and we have to add a constant. In this case, we're going to add R. R is called the ideal gas constant. So in this case, so far, we have V is equal to R times N times absolute temperature over P. The numerical value of R can be determined by putting in all the units that a gas will occupy at STP. R depends on the actual units that we're using for pressure. In this case, we're using atmospheres for pressure. So R is 0.0821. You can also solve this for pressure in kPAs or pressure in any other units. Volume is always going to be in liters. Moles, or N, is always going to be in moles. And temperature must always be absolute temperature or kelvins. The normal way that we express the ideal gas law is PV equals nRT. P is pressure, usually in atmospheres. V is volume in liters. N is the number of moles, or atoms, and it is moles. R is the gas law constant, and T is the temperature in Kelvin. Remember, we used to call this Pivnert. Try to figure out what the R value would be if pressure were in kPAs. You should have calculated R to be 8.315 liters kPAs over moles Kelvin. Take a look at table 5.5. This has several different values of R that are dependent upon the pressure values. The most common ones that you will see used in this course are the very first two listed. Actually, notice that the next two are also the same numbers, just different expressions for the units. The gas laws that we just talked about here in 5.3 were for ideal gases only. There aren't really too many gases that behave ideally, just as there aren't really children that are perfectly ideal. But real gases do behave more ideally if they have high temperatures and low pressures. We'll discuss this in a different chapter. For right now, attempt the ideal gas law problem listed below. Remember that moles are equal to mass over molecular mass. You know, sometimes this is hard to remember. The way I remember this is if I'm trying to find the molar mass, which we represent with capital M, how do I read the periodic table? Well, if I'm reading let's say, the weight of oxygen on the periodic table, it's 16.0, and that's grams over moles. That's how we read molar mass. So if we substituted M for grams and N for moles, we could rearrange this expression for molar mass and solve for moles to get N is equal to little m over capital M. Means moles is equal to mass over molecular mass or molar mass. This is going to be important, and we can substitute this in for N in Pivnert. So let's do just that. Let's substitute our little m over big M, or mass over molar mass, in for our N. Now we can rearrange the equation to solve for molar mass. We may have problems given to us where moles aren't available, but mass is. And they could be asking us for what type of gas this would be. And in this case, we would solve for molar mass, and we could look on the periodic table and most of the time determine the gas. Now let's take this a step further. We know that density is equal to mass over volume. So if I rearrange Pivnert, solving for mass and volume, and plug density in instead, I can develop the equation D equals P times molar mass over RT. So again, I can be given some information and actually calculate the density of a gas. Try these sample problems. The first one, you're going to be determining the density of a gas, and the second one, you're going to be determining the molar mass of a volatile liquid. Remember, if it's a volatile liquid, it evaporates quickly and creates a gas. If you have any questions, please make note of them for tomorrow. And that's the end of this lesson. Be sure to read this section in your book and be prepared for a possible homework quiz tomorrow.